Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire, and today I've got Matthew, who has just completed the course Linux Basics, and he'll be giving us a presentation of that. So first of all, we'll begin by seeing his code base running in simulation, and then we'll get to connect to the real robot and have it run on the real robot. Okay, without further ado, I will now hand over the platform to him so he can begin his presentation. Alright, Matthew, whenever you're ready.
Thank you very much. You see the screen?
Yes,
Down
we
here
do.
in the bottom right is simulation. Here goes the obstacle avoidance program. This works by pulling LiDAR from the simulated robot, and then for each range, there's front left, front right, left, and right. And then based on the closest point in each one of those buckets, let's call them, it then determines, oh, is this closer than a given threshold? And then uses that to make decisions on, oh, in front of me is clear, so I'm going to just go forwards. For example, here I have some debug text that says front left true, front right true. And that's it saying, oh, okay, there's nothing there. Let's go forwards. Like, let's go. And here is also debug information about what each value is extracted. Very helpful for me debugging. I also feel like it works for the enrichment of the people consuming this, so I left it there. As you see here, it's saying that front left was false, so it's kind of turning away so that it doesn't hit something there. And then, if I'm not mistaken, it's going to go, I think it will go straight. Unfortunately, it's not as fast as I would have liked to make it, but part of that is having to print out a bunch of these debug statements.
Okay, so
front left true, front right true, front true, so it's going forwards.
okay.
You can kind of track its movement by these little yellow arrows, which is neat.
All right.
Cool.
Yep.
Yeah.
Let's go ahead. Yeah.
Without further ado, I will get into the real robot. Here's hoping it doesn't get stuck in a corner because someone jammed a sign in there or something. But
let's hope not.
Even if that's the case, we'll make it work.
All right.
Well, here's the thing. There we go.
All right.
So here we have the real robot. Where's this selection go? Because that is what I need. And yeah, the web shell. And I'm just going to need the sourcing command, which is there. Stick with it. And for some reason, it's not connected to the robot. Cool.
Maybe
Let's go to the section where it says connecting to the robot and be sure I did everything right. Click on that, move the joystick around.
Can you check if it's responding to the joystick at least?
Yeah, the joystick works.
Okay, so you probably are connected. Okay.
Yeah. Now any terminal you open will show topics and services on the real robot. I'm just going to restart the process to see if that does it. Nope. Cool. Let's turn it off and turn it on again.
Did you run the Python script first? Because you have to run that one first so that the node can be found.
Oh shoot! Right, the robot interface.
Exactly.
That'll do it. Oh well.
All right, you do that when you connect again.
Yeah, yeah. Turn on. And that is the robot interface Python script. Actually, it's there. Cool. Up. The robot. Interesting.
You can click on the.
Up. There we go.
There we go. Yep.
It's not over the zoom thing. Web shell. That. Terminal. That. Slash obstacle avoider. Let's wait for this to be ready.
Mm-hmm.
Which it is. Hey, set parameter successful. Cool. So, here you'll see the robot moving front left true, front right true, front true. Set parameter successful. See? There it goes.
What was the obstacle that he... Okay, let's see. They didn't seem to be an obstacle in front of it. There didn't seem to be one, so I wonder why it turned, but let's see.
I think it was under that iteration, it was the front left was false. So it's like there wasn't something directly in front of him, but the instructions were like, hey, if there's an obstacle front left, do this. And I considered sitting down and further adding to that, but I also didn't want to, I don't know, introduce more bugs, make it introduce unintended behaviors.
Okay, I understand, yeah.
Simplicity is strength, and the instructions laid out a fairly clear and comprehensive plan. So
Okay.
I'm like, this is good enough. I'll use this.
All right. Yeah, generally that's the right way of doing it, right? Follow instructions every time.
Yeah.
Okay, but this time it did avoid the real obstacle, so that's quite cool.
Yeah. I mean, once again, it's a little slow and a little unrefined, but see, right there, it stopped itself from crashing into a wall, which is neat. So it should be turning. Keyword should be turning. Hey, there we go. And once it turns far enough, everything will be clear, and I think it'll just keep going kind of straight shot.
Okay, we see that again. Okay, it's fine. Let's see.
So, see? And there we go. Hey, it even managed not to crash into that stop sign. So, yeah. If time allows, I think now would be the time to transition into talking about my code.
Yes, let's do that.
Acceptable?
Yep.
Wonderful. So, what's this? What's this? All of the logic for this contained within one file, obstacleavoider.bash.
Yep.
Very well commented. Very proud of this code. Starting out, I have just some stuff like, hey, we're doing this. I make sure that the robot stopped, and here I am setting some variables just so, oh, I know the threshold of how close something needs to be before I need to worry about it.
I like the function that's checking validity of floating point numbers there. So, did you implement that? That one.
I actually can't remember. Part of this they did give us. I can't remember for sure.
All right, so you're running through some of the code that they gave you. It's also important that you do understand as well the tools that you're working with, right? So, yeah.
Yeah, no, I mean, this is all regex stuff, if I'm not mistaken. It's determining if the float is in fact in a valid range.
Okay.
So, here I am getting all the scan ranges. If a scan range is invalid, I just set it to 0. I felt like that was the best way to approach it. Here's some debug output. Here I am putting out for front left, front, and front right the status. This is what was showing up on the terminal, the very helpful debug that I mentioned earlier. Then we actually get into all of this, which is the logic. If all three are blocked, which I just did by basically setting a boolean, front left free, front right free, front free, etc., etc., then do all of this stuff, else do all of this stuff. And then these are all of the various conditions that I instituted, which works. And here we are down at the bottom, having a little divider, so I know what the difference is between each iteration. A sleep, just to give the robot time to catch up, and a done. So, yeah. That's the program, and the robot in simulation, and the robot in real life.
All right, and can you take us through your robot statistics file, the bench file?
Yeah. I just realized I was supposed to be running that. Whoops, I can prove that it runs on the simulation. Basically, so this program has you write a bunch of functions capable of interfacing with the robot, extracting data.
What data are you extracting from that with this file?
So I have I plus start x and start y because I need that to compute how far the robot's traveled. Then a delimiter bar, and then while true, I set a bunch of these values. These are just interfacing with functions I was given. For this class, you don't have to touch ROS itself. You touch like a Python file that interfaces with ROS.
Yes, true.
And then here, I just catted this in EOF format because it meant I could do it kind of how I wanted. So I have distance covered, yaw, position in terms of x, y, and z, orientation in terms of roll, pitch, and yaw, angular velocity, x, y, z, and IMU linear acceleration in terms of x, y, and z, which I can, if the window wants to pop back up, lab streaming. So I open this terminal and then do yeah. So there we have the delimiter bar. It's presumably extracting things like initial x, y right now. And here we go. Here's actually all of our data. So considering the robot hasn't moved since when I turned it on, it'll say 0 meters. But yaw, here's its odometry position, orientation data, angular velocity. It's currently not moving, so it makes sense why it is that way.
Yes.
And linear acceleration. It'll go off every couple of seconds, if I'm not mistaken. But you'll see my linear acceleration was 0.3, 1, and 10. And now it's, 1.2 to 1.6, 0.2 to 0.3, and 10.46 to 10.89. So the data is in fact being updated, which is cool. Also, you'll notice yaw just updated, position just updated, so it also works and is cool and helpful.
All right. Okay. So anything else?
Unless I'm gravely mistaken, that's everything.
All right. That's all good. So we'll get into a couple of questions now. So first of all, I would like to ask you, in general terms, right? What do you think is the use of base scripts, right? Because there's no point in using them without really understanding under what context should they be used, right? So
My understanding is, if you're writing like a program, like code,
mm-hmm.
that's you have Python, you have C, you have C++, you have Java.
Okay.
Bash scripts are for kind of managing processes at a higher level.
Okay.
It's like, okay, when my computer boots up, I want it to run this Python script and this C++ script.
Right. Okay.
And that's something that a bash script does really, really well. Because at the end of the day, it's basically just a bunch of command files,
Okay.
bash command files, excuse me, or not files, commands, shoved into a file.
Right.
So it's a way to perform command line tasks quickly, efficiently, and effectively.
Okay.
Instead of having to do, bash or source bash rc and then type out all of these commands every time you want to do a given action,
Yes.
just stick it in a file and run the file every time, and all of that's now semi-automated.
Yes. Very good. I was looking for that automation word, right? Okay. The next thing is I want to know, how do you source a file, and what is the purpose of sourcing a file in the Linux terminal, right? Why do we have to source a file? What are we doing in the background when we source a file?
So this is something that actually becomes more relevant when you start working with the nitty-gritty of ROS2. It wasn't actually as relevant here as I would have liked it to be, but I digress. Sourcing a file is a way to tell Bash to update the information that it has and is working off of. For example, when you're working with ROS2 properly, and you build a package and you put all your code inside of it, and you try to run it, it's not going to do anything unless you source install/setup.bash.
Okay.
Because that's what tells it, okay, I'm basically going to re-look through all of my packages and files and update all the information I have about what's there. So before, if I was trying to say, ROS2 run my package, my program, and it wasn't working, if I source it afterwards, it, assuming no other errors, would work because ROS2 actually sees what's there.
So it knows where to find those that command that you want to type in the terminal, or whatever script you want to run, right?
It's a way to give your system more updated information.
Okay.
Which is tremendously relevant.
Yeah, true. Yep. Okay, and then the other thing is, so enough of sourcing and stuff. I want to ask you about permissions, right? So how do you give executing permission to a particular file, and when you're doing that, what other like sub permissions can you give it, right? Or if you're giving it to a particular user, what three actions are they allowed to do, right, in that actions permission specifications?
If I'm not mistaken, the only command that allows you to do this is chmod, chmod, however you want to say it. And you can, there's execute permissions, read permissions, and write permissions, if I'm not mistaken.
Yes.
Which allow a user to read the file, write to the file, and execute to the file respectively. So there's that. But either everyone can see this,
right?
You can see this if you're part of a group, or only this person can see this.
Okay.
Which is really nice.
Yep. Okay, so we've got others, then we've got group, then we've got the user. Okay, as the owner, kind of. Okay. All right. Very well done, Matthew. So thank you very much. I liked your answers. So well done on that. Yep. All right.
Thank you very much.
So we will wrap it up here, and congratulations. right, everyone, this was Martin's presentation. Warm congratulations to him, and I would like to encourage all those of you who would want to come and do a presentation of their work to do so, and this will also enable you to be able to showcase your work. And until next time, keep pushing your ROS learning. Bye bye.